Refraction of light. When a light ray travels from one transparent medium to another obliquely, that is slanting, here you have to observe very carefully, the path of the light undergoes deviation. But in this particular diagram, if you observe, the light ray has not undergone any change, because it is not falling slanting, it is falling straight. So when light falls on that one straight, it undergoes no deviation, but if it falls in the slanting position, it undergoes deviation. Let us go to the next slide, which will give you a better idea. Here the light ray comes from here and it falls here. It is supposed to go straight in the dotted line, but it is changing its path. It changes its path. Instead of going like this, it changes the path like this. Then instead of going straight like this, it is changing again. It is changing its path again. This deviation of light ray is called as refraction. And refraction takes place due to difference in velocity of light in different media. Now, let us go to the next one. The velocity of light, it is more in rarer medium and it is less in denser medium. Say for example, here we are considering a glass and air. Air is a rarer medium, whereas glass is a denser medium. So what happens when it travels in air? It travels faster. When it enters into the glass, it travels slower. Then when it comes out of glass and travels in air, it travels faster. Okay. Now, laws of refraction. Actually, it follows two laws. Law 1 says that incident ray, refracted ray and normal, they all lie in the same plane. Let us consider a simple incident ray. It is incident ray. It comes to this point. And here I have highlighted a point. This is referred as point of incidence. And this is interface or plane of separation. To the plane of separation, I have drawn a perpendicular line through this point of incidence. And this is referred by the term normal. And in case, if you go for another incident ray, this is point of incidence. And through that point of incidence, if you draw a perpendicular line to this one, this is normal. So for this one, for this line it is normal. For this line it is normal. What is the use of this normal? Normal is used to calculate the angle. To calculate any angle, you will be using only normal. Now let us go to the next one. To understand this one better, we are having this one again. It is incident ray, point of incidence. The light is supposed to take the path like this, but it is refracting. That is, it is changing its path. And it once again changes the path because it travels from glass to air. Now, let us go to the second law. It is very important once again because it is book back 6th Roman 2nd question. The law says the ratio of sine of the angle of incidence and the sine angle of the refraction is equal to the ratio of refractive indices of two media. And sometimes they may ask the same question with this word, state Snell's law. They may ask you, give second law of refraction, or they may ask state Snell's law. And you have to give this formula, sin I by sin R is equal to mu2 by mu1. It's very important. Without fail, you learn this. To understand this one better, we are having a diagram here. Here it is incident ray. With the help of normal, we calculate the angle of incidence I, and we are having the value sin I. And instead of going straight, it is having a bend. And for the same normal, we are calculating sin R. So it is sin I, it is sin R. They both are not equal. Sin I and sin R are not equal. When compared to sin I, sin R is less. Now we go to another important book back question, 6th Roman, first question.